So for this question here, we clearly have a multiplication of two different functions, so we'll be using the product rule. But to make this easier, we're going to first redefine it in terms of u. We're going to let this equal e to the u times tan x, where we know that u is equal to negative 2x. So this will let us use the chain rule in our product rule and simplify some of the terms. So we're going to have e to the u multiplied by the derivative of negative 2x, which is just negative 2, multiplied by the entirety of tan x, plus still e to the u, but we're not deriving it this time, we're leaving it as is, multiplied by the derivative of tan x, which is just secant squared x. So with some, we'll plug in the term again, negative 2 times tan x, plus e to the negative 2x times secant squared x. We know that secant is just cosine reciprocal. So this is negative 2 tan x divided by e to the 2x plus 1 over e to the 2x times cosine squared x. So there's a few ways of going about this question, but there's only one way I would approach it if I saw this. So I would recognize that when I have the division of two things within the terms of a logarithm, you can write them as a subtraction. So this is ln of 1 minus ln of cosine squared 2x. And I'm going to keep using the simplification root. So ln of 1 minus, you can pull the 2 to the front because this is cosine 2x squared. We just write the 2 here as a way of not messing up, of indicating where our power actually is rather than being on the argument. So we're going to move this to the front as a coefficient. We'll have 2 times natural log of cosine 2x. And finally, I'm going to use the chain rule here. I'm going to write this 2x as u. So we'll have ln 1 minus 2 times ln cosine u, where u is 2x. Now let's start deriving. So f prime of x is going to be, we know that this will go to 0 because it's a constant. 0 minus 2 times, because you can pull out the multiplication from the function, the natural log of cosine of u. So there's 3 different functions here. So we're going to have to use the chain rule 3 times. So natural log of cosine u, so it'll be 1 over cosine u multiplied by the derivative of cosine u, which will be negative sine u multiplied by the derivative of u, which will be 2. And we will have that negative 2 times negative sine u divided by cosine u multiplied by 2. The negatives will cancel out. We'll get that 4 sine u over cosine u, which is the same as 4 tan u. And we know that u is 2x, so we'll get 4 tan 2x. So just as a bonus, the teacher made a printing error on the paper, and the E turned out to be a C. Looks like a C, and I actually thought it meant constant. So I'll show you how to derive this, where C is a constant. So any constant can be written as e to the ln, and then that constant. For example, 2 can be written as e to the ln 2, because the e and ln will cancel, and you'll be left with 2. So we're going to do the same thing. We'll get that f of x is going to be equal to e to the ln of c to the negative 2x multiplied by tan x. We're going to keep going. We can use the logarithm power rule to bring this down. We'll get that e to the negative 2x ln c times tan x is our new function. And from here, we can use the products rule. And you'll see why this helps. So f prime of x is going to be the derivative of the first function, which is going to be e to the u. We're going to call this here, u, multiplied by the derivative of this. All of this is just a constant, so this x to the 1 will go to x to the 0, and we'll just be multiplying by negative 2 ln c, multiplied by the second function in its entirety, plus the entire first function multiplied by the derivative of tan x, which we know to be secant squared x. And we'll just have to simplify this, where we know what u is, e to the negative 2x ln c, but we know that we turned c to the negative 2x into e to the u, so we can write it as c to the negative 2x, multiply negative 2 ln c times tan x, plus c to the negative 2x times secant squared x. You could simplify this, but I'm just going to leave it like this. And yeah, that's the answer if we have a printing error instead of Euler's number.